Hi, so this video today is going to be adding on to multiplying polynomials. So it is now dealing with special cases, and we're going to be using similar methods. So we'll be using the FOIL method, which is that first, outer, inner, last. And normally you use FOIL when you're multiplying two binomials, which means that it's two term multiplied by another two terms. And we're going to run through a couple examples dealing with the special cases. Our first example is x minus 7 squared. So this is a binomial squared. So what that means is you actually have to rewrite it. That squared means there's 2 there. So it's going to look like this. So it's going to be x minus 7 times x minus 7. You're then going to use the FOIL method. So you're going to do first, which is going to be, so you got first, x times x, which is x squared. Outer, so x times negative 7x, or x times negative 7 gives you negative 7x. Negative 7 times x is negative 7x. That's your inner. And then your last. So negative 7 times negative 7 is going to be a positive 49. From there, what we're going to do is we're going to combine like terms. It's going to be the negative 7 and the negative 7. So you're going to get x squared minus 14x plus 49. That is going to be your final answer because the polynomial is in standard form, which standard form means you look at the degree and you see if it's from greatest exponent or greatest degree to the least amount of degrees. Now, this next binomial that we have here is squared. So that represents, we have to do the same thing where we have 3x plus 2 and 3x plus 2. We're going to use the FOIL method because we see that we have a binomial multiplied by another binomial. So we have two binomials. So we're going to do first, so that's going to be 3 times 3, which is 9, and then x times x, which is x squared. We're going to do our outer, so that's plus 6x. Inner plus 6x. Last, 2 times 2, which is 4. We're then going to combine like terms. So we got 6x plus 6x. So we have 9x squared. This is going to be plus 12x plus 4. It is in standard form, so we are going to box out our final answer. Another example of a special case, this is actually a difference of two perfect squares. So you're going to notice you have one binomial that has addition with the same values with a binomial that has a subtraction with the same values. We're still going to use FOIL, so we're going to do first. So we're going to do x times x, which is x squared. Outer, so we're going to multiply. Inner, plus 6x. And then last, which is that negative 36. Okay, what happens in the difference of two perfect squares is that this is going to cancel. So I'm left with x squared minus 36. And you'll notice this later, but this is actually a perfect square because if you take the square root, you're going to get x. And this is actually a perfect square, which is 36. Which you would get 6 and 6. So that is why it's going to be a difference of two perfect squares. And we'll explain that more when we get later in the chapter. Now, the last example you're going to notice is a little bit different. It has variables, two separate variables. So we're going to do the same thing. We're going to do 4x squared. We're going to do outer, which is going to be negative 6. We're going to do in alphabetical order. So we're going to do x and y. You're going to multiply. Then we have plus 6xy. And then last, which is going to be negative 9y squared. These are going to cancel. So we're going to be left with 4x squared minus 9y squared. You always want to make sure you put the x first before the y. And this is another example of the difference of two perfect squares.